Now let's practice looking at these redox reactions, and we have these like skeletons of a galvanic cell, and we're going to fill the components of the galvanic cell into this diagram. We're given the total redox reaction right here, and we are also told to assume that the electrons are going to flow from the left side to the right side. So the electrons are going to go in this direction right here. That's our wire. This is our salt bridge. Bridge has a G in it. And so for us to be able to figure out what is where, we have to kind of think about the half reactions of this redox reaction. We don't have to like completely and totally analyze it, but what we do need to think about is what's a solid, what are the ions, and which directions are the electrons going. So for our half reactions, one of them has magnesium solid as the reactant, and one of them has lead nitrate as the reactant, PbNO3 to aqueous. So this is a solution. And the real important part of this lead nitrate is really just the lead. Because remember how we talked about whenever you see these polyatomic ions and they're not changing in the redox reaction, they're literally not changing. Like nothing is happening to those ions at all. They're not players in this reaction. The nitrate ions are everywhere. They're all over. They're in both of the solutions, left side and right side. So we're just going to think about the lead ions. We're not going to think about nitrate. And then over on the product side, we have magnesium ions, Mg2+, that is coming from the magnesium nitrate, this stuff right here. And we also have lead solid, Pbs. So we know that one of our electrodes is magnesium and our other electrode is lead. We have to figure out which is which, like where are the electrons going? So we're going to look at our first half reaction that we've written, and we got to figure out where the electrons are in this reaction. The left side of the reaction is a 0, the right side of the reaction is a +2. We're going to take the higher side, which is the +2, and we're going to add electrons to bring the charge down so that it matches 0. So that means that it's the magnesium that is being oxidized. The magnesium is what's losing its electrons. So that means this is our magnesium. It looks funny when I write it like that. Magnesium solid is right here, and it's losing its electrons, and they're heading down over here, this direction right there. And they are being given to the lead. So that means we've got lead over here on this side. In our solution, lead ions. In our other solution, magnesium ions. We're always matching the elements together. So on the left side, you're going to have all magnesium, and on the right side, you're going to have all lead. You're not going to have magnesium and lead mixing together on the left side or the right side. So that's it. That's the whole. Oh, we have to say which is the anode and which is the cathode. So we're going to remember red cat, which means that the reduction is the cathode, and we're going to remember oil rig, reduction is gain. This side is the side that's gaining the electrons. They're coming down the wire over to this side. So this is the cathode, and this side is the anode. Let's practice one more. Here's our next reaction. So we have zinc solid, and we have chromium chloride, CrCl3, aqueous. And what can we ignore? We've got the chlorines and the chlorines. Nothing's happening with the chlorines, so let's ignore the chlorines. They're just staying Cl- the whole way through. So the chromium on the left-hand side is a Cr3+. What's going on with the zinc? Zinc is turning into Zn2+. That's aqueous. Chromium is turning into Cr solid. Where are the electrons? Let's just focus on the zinc reaction. The left side of this reaction is a 0. The right side of this reaction is a +2. We got to take the higher side, bring it down so that it matches the lower side. So there's electrons right there. Notice I'm not paying any attention to the stoichiometric coefficients at all because I don't need to. I just need to figure out who's being oxidized and who's being reduced and what's happening where. So the electrons, it says, are flowing again from left to right, which is convention when we draw this. The oxidation is the loss of electrons. So this is our oxidation reaction. And that means that this electrode is the zinc solid because it's losing its electrons. And remember, we want to match the elements with the elements. So if we have zinc solid on the left, then we need to have zinc ions on the left. And then over on the right-hand side, this needs to be our chromium. Our electrode is the solid substance, and in the beaker is where we're going to find the ions, aqueous. This is going to be our reduction because we're going to be gaining electrons on this side, which makes chromium the cathode, and it makes zinc the anode. And what else do we need to label? The chlorine, the chlorides. Chlorides are everywhere. Everybody's got chlorides. And this is our salt bridge.